Hey y'all, what's up? Welcome back to another video with me, Miss V. I am a geometry teacher, and if you have stumbled upon my video, I'm so happy that you're here because now I get to help you with geometry, which is essentially all that I try to do on my channel. So without further ado, let's go ahead and let's get started. So today what we're going to be proving is perpendicular bisector theorem. And if you don't know what a perpendicular bisector is, I'm going to go ahead and talk about it for a second. But it's pretty simple because in geometry, the words, when we use words in geometry, usually if you break down the word in parts, it helps you figure out what the definition is. Okay, so that's exactly what I'm going to do here. So perpendicular bisector, we already know that perpendicular means that you have two lines that when they intersect, they form a right angle. Okay, so all of these angles all around are 90 degrees. Those are perpendicular lines. And then bisector, bi means two, sector means section. So bisector means that you're going to cut it into two equal sections. So essentially, if we have a segment AB and this segment CD is the perpendicular bisector, first thing, perpendicular, it's going to form a right angle. Second thing is it's going to split that segment AB into two equal parts. So it's going to cut it into two equal pieces, okay? So perpendicular bisector is a line that, or a segment that cuts another segment into two equal parts and forms a right angle at their intersection where they intersect. So what perpendicular bisector theorem says is that any point on the perpendicular bisector of any point on the perpendicular bisector of a segment, okay? Any point on the perpendicular bisector of a segment is equidistant, and I'm going to split that into two words, it's not going to fit there, is equidistant to the endpoints, of the segment, okay? So what the heck does that mean, okay? If I have a perpendicular bisector, CD, like we did in the previous one, okay? And let's say this over here is the segment that CD is cutting. So here is the right angle, and then this right here, those are the two congruent pieces because of the bisector part. If I were to measure, let's say this point right here, it's just a random point that's located on the perpendicular bisector, we'll call it P, okay? If I were to draw a line connecting P to A, that first endpoint, and from P to B, the other endpoint, over here, if I were to measure those two segments, they would be congruent to each other, okay? They would be equidistant. So from A to that point on the perpendicular, to that point on the perpendicular bisector P, and then from B to that point is the same exact distance, okay? So if this is 2 meters, then this right here is 2 meters, okay? Which means they're congruent. So now let's go ahead and prove that this theorem is true. And to do that, I'm going to go ahead and use this space right over here, okay? So I'm going to draw a little picture for us, very similar to the ones I've drawn already. And let's see, we'll do a triangle. So usually with proofs, the easiest way to do them is with triangles. Triangles are nice. They like to cooperate better than the other shapes. So let's call this triangle ABC. And let's say that this segment right here, AD, okay, that segment is the perpendicular bisector. So I'm going to give you some information. And I'm going to say that AD is the perpendicular bisector of BC, okay? So now the endpoints that I'm taking a look at are C and B in terms of the theorem, okay? So what I essentially want to prove is that AC is congruent to AB. Because in this previous picture, remember, I drew a point P on here and I connected it down here to each of them. And I showed that these two were congruent. That's perpendicular bisector theorem, okay? So even if I move this segment down, up or down, you guys are going to see how this works out, okay? So let's go ahead and prove this is true using a 2-column proof. So we're going to have some statements and reasons. And this is actually a pretty short 2-column proof. Okay. Statements and reasons. And as always, my first statement is always the given information. So AD is the perpendicular bisector, and I'm going to write PB for short of BC. And my first reason is because it is given, okay? So now, based on that, I know that 1, angle ADB is congruent to angle ADC. And I also know that BD, that segment BD, is congruent to CD. So remember, perpendicular bisector is going to bisect or cut those segments into 2 equal pieces. And the perpendicular part is that it's going to form a right angle here and here. Since they're both right angles, they are most definitely congruent. And this reason is going to be because that is the definition of a perpendicular bisector, okay? Then statement number 3, we have that AD, that segment AD, is congruent to itself, okay? So if I were to split this into 2 smaller triangles, 2 smaller right triangles, notice both of those triangles will have that side AD in common. And if you want a more in-depth explanation of that, I went ahead and I talked about it in my previous video. Okay, so that segment is congruent to itself, and this is because of what we call the reflexive property. Reflexive property. Okay. So now finally, I can show that triangle ADB is congruent to triangle ADC because ADB, ADC, they have side, angle, side, okay? So I can prove that they're congruent by side, angle, side, which means that finally I can prove that AC is congruent to AB by CP, CTC. So corresponding parts of congruent triangles are congruent. So essentially, if I were to finish, let's say, labeling this triangle, okay? So I'm going to finish labeling these triangles. Now that I've shown that they're congruent, let's talk about the parts that are congruent. So this angle is going to be congruent to this one. And this angle up here is going to be congruent to this one, okay? So what CPCTC says is that, okay, once you've shown that the 2 triangles are congruent, I've shown that these 2 triangles are the same. Now here are the angles that are congruent, and here are the sides that are congruent, okay? So that's exactly what we wanted to prove. Now, think of it like this, right? I said, hey, even if I shift this point downward, it wouldn't matter. It would still work, right? Because think of it like this. Even if I were to move point A and let's say put it over here, right? I can still draw these 2 segments, right? And I would still have AD congruent to itself. It wouldn't change anything about the proof. All it would mean is that now I'm looking at slightly shorter triangles, okay? So that's why if I prove that these 2 segments are congruent to each other, that shows that all of the points, right? Any point that's on the perpendicular bisector of a segment is equidistant to the endpoints of that segment, okay? So if you guys enjoyed this video, go ahead and subscribe to my channel. Give me a huge like and a huge thumbs up, and so I can keep producing more content for y'all. I love doing this and it's super fun. So if you enjoyed it, just let me know in the comments below, and I will see you guys in another video. Bye.